In this lesson, we're going to be talking about voltage multipliers. So if you turn to your book, if you need to follow along, you'll go to page 71, and it's going to be in chapter 2, section 8, and it's going to be voltage multipliers. So just to give you a little overview of what we're going to be doing here, voltage multipliers use clamping action to increase peaked rectified voltages without the necessity of increasing the transformer voltage rating. And we've already talked about clampers, so we've already went through that. So this right here is again building upon what we've already learned. So it says multiplication factors of 2, 3, and 4 are common in voltage multipliers, and in this chapter that's what we're going to be dealing with is 2, 3, and 4. Voltage multipliers are used in high voltage low current applications, so that's important to remember. High voltage low current applications. So the first one we're going to be looking at is a voltage doubler that is in a half wave voltage doubler. So it says, and if you look at these diagrams down here, these illustrations, again, this book is very good of illustrating this. So as we go through this, the main things that I want you to know is the circuit diagrams. We won't be doing any calculations over this, so don't be too stressed out about that. But I want you to be able to identify if it is a half-wave voltage doubler, a full-wave voltage doubler, a voltage tripler, or a voltage quadrupler. So that's the main things I want you to see. But in this one right here, the half-wave voltage doubler, we're going to look at exactly what's going on in here. So we're going to start right here. And a voltage doubler is a voltage multiplier with a multiplication factor of 2. And that makes sense, right? Double, it's like times 2. So a half-wave voltage doubler is shown in 267, which is right here. So during the positive half cycle, which is this right here, that's on the primary side. So, and then also our secondary is going to be following that same positive half cycle. It says of the secondary voltage, diode 1 here, which is in green, is forward biased, and D2 is reverse biased, which is this one here. And we all know that because this one right here, we're on the positive cycle, that this right here is going to be forward biased because this is the positive side, this is the negative side. So we know this on this particular part of the wave is going to be forward biased. We know this is going to be reverse biased. So we've already learned a lot about that. So it says capacitor C1, which is right here, is charged to the peak of the secondary voltage, which is going to be VP right here, less the diode drop. So if you look right here, we're underneath C1, it says VP minus 0.7 volts. That there is a good illustration of exactly what they're talking about right there. So it says during the negative half cycle, diode D2 is forward biased and D1 is reverse biased, as shown in part B, which is this one. Since C1 right here can't discharge, the peak voltage on C1 adds to the secondary voltage to charge C2, which is here. So when it goes to the negative part of the sine wave, then this one right here can't dissipate. It can't dissipate. So all it's doing is it's taking what it has in charge and it's adding to this one, is all it's doing. So C2, and it's going to add to the secondary voltage to charge C2 to approximately 2 times VP, which makes sense. And that's approximately because we're going to have that drop across C1, so it's going to be VP minus the 0.7 here on C1. So that amount of voltage is going to be added to C2. So that's why it's approximate. And there's also going to be things with resistances and things like that are going on in a complete model. So right now we're just looking at the ideal. So again, we've heard of Kirchhoffs Law, so it's applying Kirchhoffs Law around the loop as shown in part B, the voltage across C2 is. And this right here is basically just showing that how everything will balance out. And we know how Kirchhoffs laws work. We also know how Coffey's laws work. But we're not going to be getting into any of the calculations. So like I said, the main thing I want you to be able to identify by looking at how many diodes, how many capacitors, and the way that they're configured is what type of multiplier is it. So make sure that you understand this right here, understand a little bit about the way that it works, understand that it's in factors of 2, 3, or 4 are the most common. That's important. So as we go down to the bottom, it says, and we're still on this half-wave voltage doubler, it says under a no load condition, which means there's no load here on the output side, C2 remains charged because C2 can only dissipate if there's a load, some type of resistance to where it can dissipate. So because there's not, then it would be a charged approximately to that 2 VP. If a load resistance is connected across the output, C2 discharges slightly through the load on the next positive half cycle and is again recharged to 2 VP on the following negative half cycle. The resulting output is a half-wave capacitor filtered voltage. The peak inverse voltage across each diode is 2 VP. If the diode were reversed, the output voltage across C2 would have the opposite polarity. So all it's saying there is that this right here, if you was to take this capacitor and flip it around to where the negatives over here and the positives over here, instead of having a positive voltage, you would have a negative voltage. So that's all that they're saying. So let's go on to the next page, and this right here is going to be a full wave voltage doubler. So the first one we looked at was a half wave voltage doubler. This is going to be a full wave voltage doubler. So again, it's doing the same thing. The main thing I want you to see is how it's laid out differently. And it's all working based off what's forward biased and what's forward biased and reverse biased, depending on which wave is on the secondary. So as you see that, it's going to alternate. And again, it says a full wave doubler is shown here, and it's 268. When the secondary voltage is positive, D1, the green diode, is forward biased and C1 charges to approximately VP, which is right here. As shown in part A, during the negative half cycle, D2 is forward biased, that one's here, and C2 charges to approximately VP, as shown in part B. The output voltage 2 VP is taken across the two capacitors in series. So we're doing the same thing as in the half wave, except now we're a full wave. In a full wave, we should understand now how that should look. So it's going down to a voltage tripler. So as you get into these right here, just continue to look at how they're set up. And one of the key things is that on a voltage tripler, you have 3 diodes and 3 capacitors. If you see a voltage doubler, you see 2 capacitors and 2 diodes. So, and the the full wave voltage doubler is not too much different from the half wave, but it is different. And that's all you need to learn is how do you differentiate the two. Okay, so then when we go down to the voltage quadrupler, you'll see that we have 4, because a quad is 4. So just look at it that way if that's an easier way to remember. So 4 diodes, 4 capacitors. You just got to kind of know how it's laid out, but the main key thing is that if you know it's a multiplier and someone says what type of multiplier is it, if you count up 4 diodes and 4 capacitors, it's going to be a quadrupler. If you count up 3 diodes and 3 capacitors, you know it's going to be a voltage tripler. So, but the thing you have to take in consideration is how do you make sure that it's a multiplier, and that's why, based off this right here, if it cannot dissipate, say this C1, and here as well, it cannot dissipate unless there's a load, just the way that it's structured. So that therefore you know it's going to hold a charge. This one's going to hold a charge. Then that one's going to hold a charge. So that is going to, should tell you right there, it's going to hold energy and keep adding it up. So that's the key ways of making sure that you understand what a multiplier is. And then from there, it's just counting the number of diodes and capacitor sets. So let's look at it that way. See, there's 1 diode and a capacitor. So that's right here's a section. Then it has another capacitor diode section. As just like here, there's one diode capacitor section, 2, 3, and down here there's 4 sets of a diode capacitor. So that, if whichever way is easier for you to remember that, but there's all you should need to know on voltage multipliers. So be on the lookout for the next video, and just remember this right here is I think on page 71 and 72 I believe of the text. So if you want to look this up yourself, just go to the textbook and figure it out. So if you have any questions, let me know. Also, there will be quizzes coming out, so you will need to be able to know these things for that. So see you on the next one.